Spiral 1. About time you guys are looking, because last year we used to do this very early. Here we go. So we have a few questions here and there of topics we covered so far. Not going to say I did everything, but it's just Spiral 1. So let's start with the beginning. Some of these questions you might remember them. So first one, this is a long one, so you can use a calculator. Hopefully you have one at home. I'd much rather you do these on your own and just check the answers as opposed to copying, because then that would defeat the purpose pretty much of everything. So first question, we have certain things we have to change. So remember, when we talked about order of operations, okay, besides, we need to change some unknown value. So for example, this guy is an unknown value for me. I don't know what the value of that is. I don't know what. This is an unknown value for me, and this is an unknown value. So before I start anything, I should change those two, numbers. Okay, so I will start with that. So now, square root of 64, so we're looking for a number that multiplied by itself is 64, so that is 8. I divide that by 4, and pretty much I'm just going to change my unknowns to numbers, okay, standard numbers. So 3 to the third power is 3 times 3 times 3, which is 27. I divide that by 2, and then minus 3.5, plus, and again, square root of 25 is a number that multiplied by itself is 25, and we have number multiplied by itself that's 25 is 5 times 6 minus 5. So now it just becomes a little order of operations number. So as long as it doesn't interfere, we can do more than one operation at a time. So 8 divided by 4, this is not going to hurt anyone, so I can do this. Although we are told that we are supposed to do parentheses, yes we can, but doing 8 divided by 4, it's still not going to hurt. So 8 divided by 4 is 2. Inside the parentheses, 27 divided by 2 is 13.5. Okay, and 13.5, I'm going to subtract 3.5. And 13.5 minus 3.5 is going to give us a nice number, which is 10. Plus 5 times 6 minus 5. I can multiply 5 times 6, okay? And then subtract 5. So now all I have left over, let me clean this up, is 2 minus 10 plus 30 minus 5. Now, in this case, I will have to do it from left to right, so I'll do these two first. 2 minus 10 is negative 8 plus 30 minus 5. Negative 8 plus 30 is positive 22. And 22 minus 5 will give me the answer of 17. So you got to remember some of these, the order here. Okay. You've been doing order operations since what, 4th grade? So this is something that by now we should be very comfortable with. Question 2. Which fractions can be converted to terminating decimals, and how do you know? So again, we talked about this earlier on. If you don't remember, you might look at your notebook, or if you have a chance, use a calculator and try to find a pattern here, an explanation as to why some of these fractions will have a terminating decimal and some of these fractions won't. So I am going to try to show you. So 3 divided by 25 equals 0.12, so that's a terminating decimal, a decimal that ends, it doesn't go on forever. 5 divided by 9 is 0.55555, so I'm just going to write it here, 0.55555 forever and ever, so it's a decimal that continues on forever. 3 divided by 8 is going to be a terminating decimal, that's going to be 0.375. 46 divided by 75 is going to be a decimal that goes on forever and ever. 0.6133333 forever and ever and ever. And I could have written a bar sign, so let me just rewrite this as 0.5, bar notation, 0.613, bar notation, which indicates that this 3 is repeating. And then 33 divided by 128, it's not going to be a repeating decimal. Okay, it's going to be 0.2578125. Okay, it's just takes, let me just confirm that 33 divided by 128 equals, yeah, and it's a terminating decimal, a decimal.end. So what do this one, and this one have in common? How come those three, the first one, third one, and the fifth one, why do these three fractions terminate, don't end up as a decimal that go on forever and ever? So one of the things that we discussed earlier on is that these three fractions have something in common. If you look at their denominators, if you look at 3 over 25, 25 is made up of what? If you broke up 25 into its prime, into its product of prime numbers, it'd be 25 you can break up into 5 and 5, right? So 3 over 8, if you break up the denominator, the 8 becomes 2 times 4, and the 4 becomes 2 times 2. So the denominator 8 written as a product of its prime factors, it's 2 times 2 times 2. So, and then 128 and 33 over 128. And if you break up 128, do the tree diagram, 2 and becomes 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. So if I circle all these 2, 128, if you do the prime factorization, it's just 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7, 4, 5, 6, 7. They're all 2s. And the 25, they were all 5s, and the 8 was all 2s. So hint from this, and you probably need a few more examples, that if the denominator, okay, and if you broke the denominator into its prime factors, the product of its prime factor are made up of 5s or 2s or a combination of 2 and 5s, then you know that if you change it to a decimal, it'd be a terminating decimal. So let's look at 5 over 9. 5 over 9, if you break the if you broke the denominator 9, you would get 3 and 3, right? So 9 as a product of its prime factors is the same thing as 3 times 3, and it's made up of the prime number 3, right? So if you look at the denominator, if the denominator is if the denominator, when broken up into its prime, is a product of prime numbers, is made up of 2s and 5s, all 2s, all 5s, or a combination of 2 and 5s only, then it's going to be a terminating decimal. Any other prime number like 3, 7, 11, okay, 19, etc., you're going to get a decimal that goes on forever and ever. Okay, 75, for example. 75, if you break up 75, you break up 75 into 3 and 25. 25 becomes 5 and 5. So 75 has 5 as its prime numbers, right? But it also has a 3. And because of the 3, when I divide anything by 75, it's going to be a decimal that goes on forever and ever. Okay? So that was one of the things we talked about early on in the year. 3 is just, what do you call, subtracting. So again, this is your pre-calculator days when on, what do you call, unit 1, you have to do these calculations by hand. So in this case, what the heck was this? So if you want to write it like this, you can change that to this, plus -7 4/7. I don't know why I made this so easy, but nevertheless, it doesn't matter. So you have two negative numbers. They're just going to be a what do you call, more negatives together, if you want to think about it in those terms, right? They're not enemies, they're friends. So in a way, we're adding these two. Okay, and this one is easy to add because, so I like to add like this. My whole numbers on one side, my fractions on one. So 4 and 7 is 11. They have the same denominator, so it's going to be something over 7. The numerator is 4 plus 5, which is 9. This is an improper fraction. I can change this to 1 and 2/7. So now the only thing is that I can't have two whole numbers, right? So I'm going to add my whole number 11 and my whole number 1 and combine that to make it 12. and 2/7, but this has to be negative. So negative 12 and 2/7. Division, we're going to change this to 5 times 1 is 5, plus 3 is 8 over 5, negative. And then we're going to multiply this, right? We're going to change the division to multiplication problem, but we're going to multiply by the reciprocal, which is negative 5 over 8. There's nothing to simplify. Oh, there is. You can't simplify the 4 and the 8. 4 divided by 4 is 1. 8 divided by 4 is 2. Nothing else to simplify. So positive times a negative, which gives you a negative. 1 times 5 is 5. And 9 times 2 is 18. Final answer, negative 5 over 18. Okay, so 4. The chess club collected $124.75 from a fundraiser. 1/5 of those funds will be used to buy new chessboards, and 3/4 of, I guess, the remaining money, right? 3/4 of the remaining money will be used for tournament fees and transportation. So let's figure out what 1/5 of 124 is. So 1/5 of 124. So of means multiplication, right? So if I were to try to find out what 1/5 of 124.75 is, I would do 1/5 times 124.75. This is a multiplication. This is a decimal, okay? So just be careful. So now you can see that this is going to be, and we can put this over 1, right? So it's going to be 1 times 124.75 over 5 times 1 is 5. So if we divide that, divided by 5, it means that we're going to use $24.95 are going to go for new chessboards. So therefore, I have to find out how much left over, right? So if we spend this on chessboards, I had 124.75. 1/5 of that is 24.95, so I'm going to subtract that value. And I'm going to get minus 124.75. I'm going to have a leftover of $99.80. Now, from this point, from this balance, what I have here after I bought chessboards, 3/4 of that money, 3/4 of this money here, will go for tournament fees and transportation. So maybe the chess team has to go take the bus, the Metro cards, pay some entry fees for tournaments, and so let's figure out what that much. So 3/4, and again, you can take the same idea. 3/4 times $99.80, right? I'm just gonna put a little X in here. Just so that you maybe, although I hate putting that because I don't want you to confuse that with a variable. So just for now, so that you don't think it's a decimal, it's literally multiplication. So 3/4 of $99.80, it's going to be, well, if you multiply, right, you're going to get 3 times 99.8 equals 299.4, and 4 times 1 at the bottom is 4. And if you divide that by 4, you're going to get that 3/4 of that is $74.85. So that's going, that money, this money is going to go for transportation and tournament fees. So you had $99.80 left over. Subtract 74.85. Subtract some minus that value, and you're going to have $24.95 left over. So what would you suggest? It says list 2 suggestions you would give the chess team on how to best spend the remaining money. Maybe they can buy books or software, like a software for a game, a chess game, a chess computer game, so they can practice. Let's say they can buy books on chess, on openings, on movements, on strategies. Okay, and I think that would be within their budget of $24.95. Okay, or maybe even a little pizza party. Okay, you can get you can get a pie, maybe 2 pies even, and a bottle, a 2-liter bottle of soda. Okay, so that would be my suggestion. Next one, so we have to know, you have to know how to add, subtract integers, right? So this is so I guess, again, we can change the subtraction to an addition. I think it's easier for you to see what's happening. So you're combining two negative numbers. So in this case, you do have to add them. 4 plus 3 is 7, 3 plus 7. So negative 34 plus negative 73 is going to give you negative 107. Okay. Over here, it's not the multiplication that we're concerned with. It's you knowing what the sign is going to be. So we have a positive and two negatives. So positive times a negative is going to be a negative, and then a negative times this negative is going to be a positive. So the whole thing here is eventually going to be a positive number. 6 times 3 is 18. 18 times 5 is 90. So the answer to this is positive 90. Okay. Combine like terms. If you like to rearrange them so the like terms are next to each other, you can do so. I will do that. Negative 5m plus 12m, and let's say negative 8m squared minus 20m squared, and then finally let's bring that negative 15m cubed to the third part all the way at the end, because that has no one to combine with. So let's combine these two. Be careful. It's a negative 5m plus 12m, and that gives you positive 7m. I don't need to write the positive. The second thing I'm going to combine is these two. It starts from this minus sign, so it's negative 8m minus 20m squared. So it's going to be something m squared. And negative 8 and negative 20 is going to give me negative 28m squared. And that last term just attaches at the end. Okay. This one is also combined like terms, but it has a little bit of the distributive property. So we have 14. The 14 is going to do absolutely nothing. So let's distribute 6, the negative 6 here, right? So negative 6 times w is negative 6w. Negative 6 times negative 8 is positive 48. There's a negative sign here in front of the parentheses here, so remember, put a 1 in there if you like. I think that's easier. So now we have negative 1 times 9w, which is negative 9w. Negative 1 times negative 15 is going to give us positive 15. Let's combine like terms. So we got the 14, the positive 48, and the positive 15. So it's 14 plus 48 plus 15. And then we have negative 6w and negative 9w. So we're going to combine these three, and then we're going to combine these two. 14 and 48 is 62, and 62 and 15 is going to be 77. Positive, that was easy. Negative 6w and negative 9w is going to be negative 15w. Okay. 8. Explain why negative times a negative is a positive using the following example. And this, you might have to go back to your notebook. So before we go over this, let's go over as to why a pause. So let me stick with 3 times 5 is positive because we're taking 3, right? 3 groups of 5. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 3 groups of 5 is going to give us 15. And if they're all positive, be positive, 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 it would be 3 groups of 5 positives, and if you put them all together, you get 15 positives. That's why a positive times a positive is a positive. Now, let's say 3 times negative 5. So we're talking now, here's one group of negative 5, 1, 2, 3, 4, 5. And we're going to have 3 groups of that. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So remember that multiplication is repeated addition, so we're adding negative 5 plus negative 5 plus negative 5. So 3 times negative 5 gives us negative 15. So that's easy to explain. Now, we have to explain why negative 3 times negative 5 equals positive 15. How is it that we can explain that? So one of the ways we can explain that is to use the distributive property. So let's see what here. So now let's think about this for a second. So what we have here is -3 times parentheses plus 5 plus -5 equals 0. Let's see if that's true. First of all, -3, let's do the inside the parentheses first. Inside the parentheses, I get 5 plus -5, and plus 5 plus -5 is 0, right? Because it's a +5 adding to a -5, that's going to be 0. So that equals 0. And then if I multiply -3 times 0, I get 0, and 0 equals 0 on the other side. So I know that this is what you call true. So keep that in mind. Now, let's do this, but this time instead of doing the inside the parentheses first, let's actually use the distributive property. So it's going to be -5 times 5, and I'm going to write this down. -5 times 5 plus -3. Did I say -5? Sorry, -3 times 5, and then plus -3 times -5. -3 times -5, and all that has to equal 0. Right? So -3 times 5, we already, we already talked about it over here, right? That -3 times 5 is going to be -15, right? So it's a positive times a negative. Sorry, a negative times a positive equals a negative, and this one will be 5 groups of -3, and that would give you -15, right? So now plus, even if you didn't know what a negative times a negative is, if you didn't know that, you still do know one thing, that this plus whatever this is going to be has to give you 0. Now, the only way for this to be 0 is that if you multiply these two numbers, it has to be what? +15 or -15? Well, if it's -15, is -15 plus -15 0? No, it's not. It'd be -30. So can't be -15, it has to be +15. So a negative times a negative, in this case, right, we're showing you that it had to be a positive in order for our original sentence to remain true, which have to be that -15 plus 15 equals 0. Okay, so this is one way of proving it using the distributive property. So again, up to this part, we were okay, right? And we didn't know what a negative times a negative was, but in order to make this sentence true, the only thing that -3 and -5 can be is 15 positive in order to equal 0. Okay, so therefore, we assume that from that, a negative times a negative equals a positive. 9. So this one, we're going back to your calendar project. So I'm asking you to create all the types of equations. So I'm going to, I don't know, so you're definitely going to have different numbers here. So I'm just going to pick an easy one. Multiply both sides by 3. I get 3y, and then 6 times 3 is 18. I'm going to add, I don't know, 3y. I'm going to add 9 to both sides. And 18 plus 9 is 27. The reason I added 9 is because the next step is going to be to create an equation with distributive property, and that makes it easier for me to, factor, right? So I can go like this, and y plus 3, because it's the same thing. 3 times y, if I do the distributive property, I get 3y, and 3 times 3 gives me 9. And nothing on this side, right? So I just added distributive property. Now I want to add some variables to both sides, so I can do 3y plus 3. Let me pick plus 4y on this side, and I want to add 4y on the other side. So I'm going to add it in this format: y plus 27 plus 3y, only to make it a little prettier. Did I add 4y on the other side? I did, because y plus 3y is 4y. So I'm done. So now I have one-step equation. The answer, a one-step equation, a two-step equation, an equation with variables, an equation with variables, equation with distributive property, an equation with distributive property and variables on both sides. We also need one with a fraction. So the one with a fraction, I would pick this guy and change it to a fraction. And I don't know, let's divide. So I want the coefficient, meaning the number next to the variable, to be a fraction format. So I'm going to divide the whole thing by, let me pick 5. So if I divide the whole thing by 5, I'm going to get, so this is what I have. I'm going to divide everything by 5. And now I have a equation with fractions, so let me just clean that up. I would get 3/5 y, there's no simplifying to do there, plus 9 over 5, I'm going to change that to a mixed number. 5 goes into 9 one time, 4 left over, 5. And 27 over 5 is 5 2/5. So there is my equation with a fraction. Okay. I'm going to take the same fraction and change that, same equation, and change it to an equation with decimals. So here's my equation. So I'm going to divide everybody by 10. Every single term in here I'm going to divide by 10. If I divide everything by 10, 3 divided by 10, okay, I'm going to get 0.3. I move the decimal 1 to the left. Y plus 0.9, and the 27 becomes 2.7. So I just created an equation with decimals. And I'm asking you for an equation with decimal where the coefficient here is a decimal. Okay. Solve and check. So I get distributive property 3 times x and then 3 times 4, so it's 3x plus 4 plus 5x equals x plus 48 plus 4x. I can combine like terms now. 3x and 5x is 8x plus 4. On the other side, I can combine this x and that x. I get 5x plus 48. I have variables on both sides. Let's get rid of one. Let's get rid of the 5x. So minus 5x on this side. Let me make my line in the middle. 5x minus 5x on that side. 8x minus 5x is 3x plus 4. These two go bye-bye, and I'm left with 48. I'm going to now, if you can, now I have a two-step equation, which if you so choose, you can make a little story. You have a variable x, which is being multiplied by 3, and then add 4 to give you 48. Using inverse operations, you will do minus 4 on both sides and divide by 3 on both sides. So let's do minus 4, minus 4. 4 goes out. And I am left over with 3x equals 48 minus 4 is 40 something. 44? Really? Did I do something wrong? 44? I didn't want, okay. So, and then divide both sides by 3. I'm going to get x equals 44 over 3, and that's completely fine. Okay, completely fine. Now your check is just going to be a little bit messy, but nevertheless, it's still something that you should be able to do. So we found our value of x here. So now we just got to replace 44 over 3. 44 over 3, and everywhere you see an x, so you're going to get 3. And I'm going to replace this guy, this guy, this guy, and this guy was 44 over 3. So you get 44 over 3 plus 4 plus 5 times 44 over 3 equals 44 over 3 plus 48 plus 4 times 44 over 3. Yikes, sorry for picking, I should have picked a different one. Nevertheless, so now I'm going to get 44 over 3 plus 4, and it's going to be 3 times. 44 over 3 plus 4 is just 4, and 44 over 3. Plus, I can multiply these two. I'm going to get 5 times 20, so it's 220. 220 over 3. And on this side, I get 48 and 44 over 3 plus 176 over 3. Hopefully that all makes the same. I'm going to change this to an improper fraction, and it's going to be 3 times 12. 3 times 4 is 12 over 3. 12, 56 plus 220 over 3. Let me do the left side. This is going to be 56 plus 200. 56 plus, and this is going to be 320, so it's going to be 70. And 70 times in a second, so it's 220 divided by 3, 70, 21, 1, sorry, it's not 70, it's 73, 73, and 1 over 3. I probably lost you now. 73 and 1 over 3, and that's just gonna give us 9, 129 and 1 over 3. I think I messed up somewhere. Well, let's try. On the other side, you get 44, 48. That's 48 and 44 over 3. I can add those two. Sorry, I don't know what I'm doing, but I can add those two, which I will. And 44, 10, 220 over 3, 44 and 28 over, so that's, again, it's going to be, I think that's going to be the same. Nope, I messed up somewhere. 3x, 5x, minus 4, minus 4, minus 4, 44, 3x, 44 over 3. I don't know where I messed up. Okay, so I shouldn't have given you a problem like this to begin with, only because it defeats the point. Divided by 3, 44 over 3. If you got this far, leave it. Okay. I'm not going to waste time, so leave it. You don't have to do check for this one. 11. Solve and graph. Hopefully this is less of a pain to do. Distributive property first. You get negative 4y plus 8 less or equal to 16. Let's do minus 8 on both sides. And 16 minus 8 is 8. Less than, this is 0, negative 4y. 4y. We're going to divide both sides by negative 4. And these two become 1, and y is going to be greater or equal to negative 2. Remember, we have to flip the sign to the other side. If you want to graph, when divide, we're going to graph this. So here's negative 2, negative 1, negative 3. We're going to shade, and we want numbers that are greater than negative 2 and numbers that are greater than negative 2 on this side. Do a check. So for do a check, I want you to pick a number that's greater or greater than negative 2. So I would pick 0. 0 is here, and 0 is on that side, so it makes life easier if you pick 0. So negative 2, 2 times 0 minus 4 is less or equal to 16. Let's see if that's true. Negative 2, 2 times 0 is 0, and 0 minus 4 is negative 4. Less or equal to 16. Negative 2 times negative 4 is positive 8, and 8 is less than 16. So I know I am good. Okay, but that was simple. Writing an equation. So Ted works at a shoe store. He earns $174 a week plus $225 for each pair of shoes that he sells. Last week he took home $288.75. If he sells more than 50 pairs of shoes in a week, he gets an extra $50. Will he get the bonus? Well, let's see how many shoes he sold. So he gets $174 for sure, no matter what. Plus $225 for each pair of shoes. For each pair of shoes. And last week, this 175 plus the 225 per each pair of shoe that he sold, he took home a total of $288.75. Okay, so he got the 174 that he gets no matter what, and then he gets a little extra for every pair of shoes that he sells, and that totaled to $288.75. So let's find out how many pair of shoes. So let's remove what he got, which is 174, right? So he gets that no matter what. That's like his guaranteed money per week. So that's gone. So we gotta subtract 128. So we're gonna be left with 2.25p pair of shoes. And if you subtract here, you get 75. Bring the decimal 4, 1, and 1. So you're left over with $114.75. So that $114.75 he earned as as his commission, I guess. 114.75 divided by 2.25. 114.75 divided by 2.25 equals 51. So if I divide this by 225 and divide this side by 225, right? It's going to get me that P, the number of pair of shoes that he sold, was 51. So he sold 51 pair of shoes last week, and each pair of shoe that he sold, he got $2.25. So the question is, if he sells more than 50 pair of shoes in a week, he gets an extra $50 bonus. Well, if he did sell more than 50 pair of shoes last week, he sold 51. So on top of the $288.75, he's going to get an extra bonus of $50, hopefully at some point this week. Okay. Last one. Yeah, last one. Wasn't that bad. Maggie has at most $89 to spend this week. She wants to watch 2 movies at $12 each, eat dinner with her friends for $35, and buy comic books for $2.99. So let's set up an equality here. So at most, which means whatever she's going to spend has to be less or equal to 89. She's going to watch 2 movies at $12.50 each, which means, well, one movie is $12.50. A second movie would be $12.50 times 2, so that's she's going to spend $25 on movies. Plus, she's going to go out to dinner with her friends for $35. Plus comic books. Do we know how many? We don't know how many comic books. So she's going to buy $2.99 per comic book. So the movies plus dinner plus the comic books have to equal or be less than 89. So I can combine these two, right? 25 and 35. I know that that's 60. So $60 plus $2.99C, which is the price of the comic book, right? And however many comics she's going to buy has to be less or equal to 89. Now we get to solve this. It's minus 60 over here. Minus 60, right? So the $89. And basically it's saying that we're going to subtract. We're going to subtract the movies. We're going to subtract what else? The dinner. So after that, she's going to have $29 left over. And with $29, let's see how many comic books she can buy. Divide this by $2.99 and divide this by $2.99. Cross out the number of comic books that she can buy. So it's going to be 29 divided by 2.99. It's going to be 9.698, blah, blah, blah. Well, anyways, so the greatest number of comic books she can buy is 9, because you can't buy 9.69 of a comic book, right? So the greatest number of comic books she can buy is 9 comic books. Okay, so that gives you an idea what a spiral will be. Okay, and that's that.